Hello, I'm Lindsay, and I'm working with Gabriel on assignment 6 for ENGI450. We are going to be discussing the topic of cognitive engineering. So first we want to start out with the definition of cognitive engineering. One of the best definitions that we found says that cognitive engineering, which is also known as cognitive ergonomics, focuses on the fit between human cognitive abilities and limitations and machines, tasks, or environments. So a few examples of cognitive engineering would be designing machines or computers that are easy to use, also creating signs that are simple to understand for people. And another example is designing machines that will reduce human error. For instance, if you're building an airplane or a rocket, you want to avoid anything that's going to lead to catastrophic error if a human makes a mistake. So one of the biggest sections of cognitive engineering is information processing. So there's four main theories of information processing. The first and most widely accepted theory is the stage theory, and this focuses on how information is stored in the memory and talks about the three stages of memory, which we're going to talk about a little bit more later. Also, there's the level of processing theory, which learners utilize different levels of elaboration as they process information. So information that they are new to process with less elaboration than something that they're repeatedly doing. Also, there's the parallel distributing processing theory. Information, this is kind of the opposite of the stage theory or the alternative. And this is where information is processed simultaneously by several parts of the memory rather than sequentially as stated in the stage theory. And then connectionistic theory is similar to the previous theory, and this is saying that information is stored in multiple locations, and instead of sequentially like the stage theory, there's different connections and networks in the brain. So here's a little diagram that kind of shows what the stage theory is saying. So first is the sensory memory, when a human senses something in their environment. Obviously, if they're alerted to something, they're either going to forget it or they're going to register that to their short-term memory. And from the short-term memory, something will stay in your short-term memory if it's being repeated over and over. So if you're studying for a test, it'll stay in the short-term memory. From there, it can either obviously be forgotten or it can be stored then in the long-term memory. In the short-term memory, it can also go into a response. So if you're trying to remember something for a test, this is answering the question. There's four principles of information processing. The first is the assumption of limited capacity, which is basically saying that the human mind obviously can only hold so much information in memory. Also, a controlled mechanism is required. So basically what this means is certain activities require more processing power in the brain. Obviously, a new task that you're learning is going to take more processing power than something that is being repeated over and over that you've done for a long time. The third principle is the two-way flow of information. The human brain gathers things from its environment, and then we take things from our memory to put them back into the environment to answer questions or communicate with people. And then the final principle is humans are genetically prepared to process and organize information in specific ways. So obviously a baby processes information in a different way than an adult. Males and females process information in different ways. Situational awareness is also a section of cognitive engineering. So first one has an awareness of information. Then this goes into the comprehension of that information and understanding the meaning. And then once you have comprehended the information, then there's a projection of a future status and what to do with the information that you've gained. This is often used in military because they have to be so alert and know what's going around at all times. So there's a number of different things that can result in a loss of situational awareness. The first is attention. This is basically if the attentional demands of something are too strong, because obviously a human can only focus on something for so long. There's also pattern recognition. If someone's unable to recognize patterns or stuff that's being repeated over and over, they can not be aware of their surroundings. Also, there's a workload factor. If you're trying to remember too many things or too many thoughts are going through your head, it also can result in a loss of situational awareness. There's also the mental models factor, which is an inadequate understanding of the environment around you and not understanding the state in which you're in. And then finally, working memory. If you can't gather your short-term and long-term memory and make educated hypothesis about the situation around you. Then you can also have a loss of situational awareness.
A cognitive engineering approach to human error relates errors to failures in the way that an engineer or a worker processes the information and how that information is processed in their mind in a skewed way due to cognitive biases. And when you study a lot of engineering disasters, you can get to the conclusion that most of these engineering disasters could have been prevented would have had not for some sort of human error that directly or indirectly led to these disasters. And we will discuss some of these applications on the next page. But briefly, some of the types of human errors in the engineering process that are studied in cognitive engineering are the error in planning, which is a mistake in your initial planning stage where you don't account for a certain thing, or you don't measure the right dimensions of a certain object. Then there's the error in storage, which is the lapse between your planning and execution. There could be environmental factors or a certain condition that changed and was now is there and could lead to a catastrophic error. And then the last one, which is one of the most common ones, is an error in execution. That's a slip when you're actually in the process of building something or in the process of constructing a building, anything. And when it comes to human error, there will always be a probability of error. Humans, that we make mistakes as humans. So this is a very important quote, which I think should be the highlight of how an engineering approach to human error should be. And this says that the total elimination of human error is a futile pursuit, but systems should be designed so that they are error tolerant in the sense that errors can occur without leading to unacceptable consequences. The mental model theory is a very important theory. We use it every day, and it uses deductive, probabilistic, and logical reasoning, where an individual's thought process is based on axioms, assumptions, or cognitive biases, where a conclusion is deduced based on what is true or what has been true, and ignores some of the false premises that do not support your conclusion. And the issue here is that this can lead to systematic error based on reasoning that if it holds true to most cases, it must hold true all the time, or if it holds true in the past, it will hold true in the future. And some of these major cognitive biases or attributes that lead to the systematic error include the overconfidence in estimation and plans. That is, as an engineer, you're overconfident in your findings and you cease to be more specific and look for other options of errors. Another one is that previous experiences are often based for future choices. That is, that you're determining your future choices based on what was true in the past. And one last one, which is very common, is when you accept confirmatory evidence that supports your conclusion, but you ignore contradicting evidence. And some applications of the mental model and how these cognitive biases affected a lot of engineering disasters. The first one we're gonna look is the Challenger space shuttle. And there was a large overconfidence from NASA and miscommunication. And NASA had believed that the failure probabilities were 1 in 10 to the 5, but the actual probabilities were way higher. And after the incident occurred, there were a lot of studies that found out that the failure probabilities were very off from the actual probabilities. And also, they had deemed that the launch was unfit if the temperature was below 53 degrees, and due to an overconfidence from engineers and from NASA, that morning the temperature was 29 degrees and they still decided to launch. Another example that goes to the third mental model cognitive bias, the accepting confirmatory evidence, ignoring the contradicting evidence, is the Tacoma Narrow Bridge. When they designed this bridge, they did a lot of studies on the wind pressure, and it was meant to withstand horizontal wind pressure of 200 miles per hour, but they didn't acknowledge the vertical wind pressure. And in the end, this is what led to a huge pressure on the plate and the cables that led to the bridge collapsing. And these are some applications of the mental model and how they led to some human error. And these are some of our sources, and thank you for listening.